Thank you very much for that introduction. So, as he mentioned, I work for OpenDaylight, and I by and large manage the overall open source community around OpenDaylight, as well as help to manage the nonprofit organization that supports OpenDaylight. I'm going to talk a little bit about what OpenDaylight is. It seems as though there's probably a pretty significant diversity within the crowd as far as those very familiar with OpenDaylight and those maybe not so much. So I'm going to cover exactly what OpenDaylight is, what our goals are, kind of talk about where we are, what the current release is doing, as well as what the next release is looking like, and finish off with where to find out more about the project. With what OpenDaylight is, again, from an open source community standpoint, we're really trying to bring the industry together to create a common platform that everybody can use as the basis for their SDN solutions. As I mentioned on Tuesday in the workshop, we need to consider open source never as a solution, but really as a technology. Many people take open source technologies and they combine them together. They add their own additional functionality around it. They add support, they add training, they add all the infrastructure necessary to create a solution for their end users. But by and large, open source is not a solution. And so that's something very important to remember. By getting the industry together and working together on a common platform, the goal here is to actually significantly accelerate the adoption of SDN by creating this common platform that everybody can use. We've had a great deal of success in bringing many of the industry players together to work on this common platform. You'll notice that the most successful open source projects are actually very pluggable and very platform-centric. There are many different components of open source that are available today. And again, the most successful are ones that are created in such a way so that different technologies and different participants can take that platform and they can modify it to solve their specific needs. One of the great benefits about open source is that by having such a pluggable architecture where everybody can combine to build their own additional functionality to serve their own particular needs, it's often very leverageable by other members in the community. This is one of the reasons why open source is the basis of very, very significantly rapid innovation in a variety of places. One of the oldest examples is Linux. And if you look at Linux as an open source technology, again, being a pluggable platform, allowing different organizations to be able to leverage that technology, has allowed it to rapidly and consistently adopt new capabilities of hardware and the rest of the ecosystem around servers. OpenStack is similar and has been around for the last 4 years now, 3.5. OpenStack is also a very solid platform for doing cloud work with many different organizations contributing to it. It's a very pluggable architecture, so it's very extensible, and it continues to grow in functionality at a very, very rapid rate. Similarly, OpenDaylight, as a pluggable architecture, is looking to do that for the SDN ecosystem and also to help facilitate NFV. So what is OpenDaylight building? Quite simply, again, it's an evolvable platform. One of the things that's different about OpenDaylight that you'll notice in the architecture diagram is that it is not just OpenFlow centric. We're not quite sure, given where we are with within the entire SDN movement and how young it is currently, we're not quite sure if OpenFlow is going to be the only protocol that's going to be usable, and certainly we have a legacy of devices that are out in the network that also need management and control that are not working with OpenFlow. So one of the key tenets of the project is to be able to support different types of protocols, different types of connectivity to different devices over a very long period of time. By providing a common set of northbound APIs as well as the ability to plug in different southbound plugins, creating that kind of versatility is again key to the project. From an industry value standpoint, again, we're really looking to create this common code base that users can use independently, vendors can use as part of their product and part of their solutions, creating a common base that, in essence, helps to guarantee interoperability across different vendor solutions. That's one of the great keys, or one of the great things about open source is because it's common code, you increase the level of interoperability that you can expect between different components that are leveraging that same technology. And again, from an innovation standpoint and rapid time to market with regard to features and capabilities, providing a platform that the entire industry can be working on as opposed to independent vendors is really the key. You know, when we think about SDN and the need for a controller, you know, everybody needs a controller, everybody needs that core platform from which they can build their solutions. And, you know, in the past, before the open source movement came in, everybody would build their own from the ground up. And quite frankly, because so much of that core code is really non-differentiating, it was a waste of time and money for all the companies to do that same creation independently instead of being able to leverage each other's work. So with this, again, we're working to bring a very rapid innovation and a rapid evolution of SDN to the industry as a collective. And so this slide just kind of talks a little bit about some of the momentum. Now, this project was launched in April of 2013, so we're a little more than a year old. We had our first release, which was Hydrogen, in February. And we've had a great deal of success and a great deal of momentum as a project. Again, I don't know how many have heard of OpenDaylight prior to this week's presentations, but as you can see from many of the vendors who have been speaking, it's often prevalent in either their current work or their product strategies moving forward. We sit at about a little over 1 million lines of code. This is mostly Java code, although we do have a variety of other languages, and we continue to debate as a community the method and the way of actually integrating different languages to be very successful as an open source project. Sitting at about 181 contributors, we won Best of Interop grand prize as well as the SDN category. This was quite surprising to me, to be honest, because Best of Interop is typically given to solutions, again, instead of open source projects. Indeed, OpenDaylight was the first open source project to ever win the grand prize at Interop. And again, I think, well, the judges told us that, you know, given what this project is doing to the industry and for the industry, they considered it a very significant set of technologies that were important for the SDN movement, which is why they ultimately had us win. Again, a variety of other awards. We're sitting at about 36 member companies. Again, released Hydrogen in February. Second release is Helium, and it is due out on September 29th. And we've currently got 3 products that are based on OpenDaylight, with many more in different companies' product plans moving into the rest of 14 and into 2015. Okay, it looks better up there. That's good. So this is the architecture for Hydrogen. First, I want to note that, you know, we think about a controller as a core piece to managing devices on the network. OpenDaylight also considers some level of applications on top of the controller as something that is in scope for the project. For example, we have a denial of service application with accompanying services inside the controller as one of the features that is part of the Hydrogen release. But if you look at this diagram, we've got the applications that sit above a set of RESTful APIs. You can also interface with the controller through OSGI. Again, being Java-based, we're also OSGI-based. So you can interface through OSGI if you're on the same box as the OpenDaylight controller, and that's what your configuration looks like. Otherwise, you can use the RESTful APIs. There's a set of base network service functions, topology manager, statistics manager, switch manager, the forwarding rules manager, host tracker, and an ARP handler. Additional services are the affinity service, which is the first crack at creating some level of policy management, identifying hosts, groups of hosts, the links between them and their relationship. So kind of lifting up the interface and the abstraction to the network from just doing straight level 2 or level 3 interface APIs. And there was significant work in Hydrogen around being supportive for OpenStack. We have a variety of different virtualization technologies that can be leveraged. One of them is OVSDB. Another one is, as was mentioned just previously, NEC's contribution of the virtual tenant network, as well as OpenDove that was originally contributed by IBM, as 3 different technologies for doing overlays. Additionally, there's a Lisp service for the Lisp protocol. And for the OpenStack interface currently, we basically match the Neutron APIs for the ML2 interface call for call. So when an application calls down into Neutron and OpenStack and the OpenDaylight plugin is present, Neutron just passes that call directly to the OpenStack service here. And then depending on how you've configured OpenDaylight, one of those 3 virtualization technologies, OVSDB integration, VTN, or OpenDove, are then leveraged to create your virtual network. Again, so looking down at the bottom, we've got a variety of protocols. Both OpenFlow 1.0 and 1.3 are supported in the first release in Hydrogen, as well as OVSDB, NetConf, Lisp, BGP, PSEP, and SNMP. Many folks kind of look at that and say, SNMP, that's an interesting choice. And indeed it was, but this really typifies the way an open source project works, right? So there was an organization, ITRI, who wanted to work and explore SDN concepts, but they didn't have any OpenFlow hardware. The only thing they had were devices that actually, worked with SNMP. Yet they wanted to participate and again, experiment, try to understand SDN, what they could do, and so forth. So they proposed doing a southbound plugin that would implement SNMP. Now, while many of us aren't quite sure if that will ever be full production capable and interesting to any particular set of other end users, it also doesn't cause any problems. Right, and as a good open source project, if somebody wants to do work and wants to come to your community and participate and it's not going to mess up anybody else, you by and large say yes. Right, and so indeed we have an SNMP southbound protocol, and it has been used by others in a variety of places, surprisingly. So in the end, it is interesting to more than just that organization, and it has been helpful to the community at large. In the middle is the service abstraction layer. And this is a key component, again, of the controller in general, and is one of those things that really allows it to be pluggable and flexible. So there are actually 2 different versions of the service abstraction layer. The first version was really a pretty bare bones version, and the second version is called the model-driven service abstraction layer, or the MDSAL. The MDSAL is where things are moving as far as what we want to do as a community. And it's using Yang as a device to create models and then to automatically generate code for both northbound APIs and southbound APIs that tie in that RESTful API set to the southbound plugin when a new plugin is created, when a new set of northbound APIs are looked for, and so forth. And again, the key behind that service abstraction layer is creating some level of common interface where possible for the northbound services as well as the northbound applications riding above OpenDaylight, and then parsing those commands out to the proper southbound plugins as they need to be. So, for example, one of the activities that we're working on as well is, we expect to have an OF config plugin eventually as well. And many of the commands between OVSDB integration and OF config are very similar. So having a common northbound API, but parsing that out to a different southbound plugin depending on the device you're talking to and the protocol that it is using is really the idea behind creating that level of abstraction for those services. specifically out of scope for OpenDaylight is the components below the dotted line. So we are not in the business of creating OpenFlow-enabled devices, OpenFlow vSwitches, or any kind of additional virtual or physical switches. I've had a variety of questions while here, basically asking, so what's the relationship to OpenDaylight to NFV? So I thought I'd put this diagram up and talk a little bit about open source in general, as it may apply to NFV, as well as OpenDaylight in particular. This diagram is one of the original architecture diagrams out of the white papers from the ETSI ISG NFV group. And one that I use to kind of describe about where different components for open source may reside in this stack. Again, if you remember me saying that open source is a technology and not a solution, this is a prime example. Right? There are various pieces of open source technology that are very valuable to providing an NFV-based solution set. And most likely will be incorporated, again, either through open source activities and or through vendors' products and so forth, and ultimately end users' products that they create. One of the first keys is the hypervisor, right? So KVM, Zen, Linux containers are all somewhat possible candidates here inside of this stack. As we look at this diagram and we look at the actual virtual network functions, by and large, those are going to be running on Linux, so I don't even include Linux as the operating system as another piece of open source as part of this puzzle. But as we look at the hypervisor virtualization layer, again, KVM, Zen, and Linux containers would go there. Another thing about NFV is that you need some kind of a fast transport going between those virtual machines and down to the actual hardware NICs. Again, Uri was talking about DPDK and extensions and enhancements to OVS to really allow that for NFV. That's another set of open source activity that will continue to evolve, again, in support of NFV in general. Then you have a controller, right? Something that's actually managing those network elements, putting those flows together, creating the enablement of service chains and so forth. So OpenDaylight as a controller sits across the virtualized network and also ties into the orchestration for that. And then above and beyond that, you've got some kind of an infrastructure as a service platform, the most popular being OpenStack. I'll note here that OpenStack actually just started specifically within their technical community a work group to identify, document, and begin work on gaps that exist inside of OpenStack that are recognized as necessary for NFV types of deployments. And so if you want to get involved in that, again, great thing about open source communities is it's open to all. And oddly enough, I think the first meeting that they had was just a few hours ago. But if you want, I can get you additional information on that if you come see me afterwards. So you see that the bottom part of this picture is pretty well painted with potential for open source. Again, also what is common in open source is the lower down and the more platform-centric the technology, the more likely open source will serve the purpose. So right now, there isn't really anything that one can point to for open source OSS BSS or open source high-level virtual network functionality orchestration. May very well never be. Maybe some organizations will get together and try to do some work there. Today, there isn't anything that I know of, and again, probably won't happen, but again, with the industry looking to work on NFV and leveraging significant amounts of software that's already out there from the open source community as the core platform, again, that's a great use of open source. Key themes for OpenDaylight in 2014 and 2015. Stability, scalability, and performance. Again, this was our first release that we had in February. As first releases go, good functionality, a great gathering of the community, so we're very, very happy with the way all that went. The code continues to need evolution, again, and hardening and so forth, and so significant work is being done there. Improving our clustering technology, improving the way we do security across the project, as well as adding, functionalities such as, role-based access and so forth, and of course, performance. Another thing about the project, which is also not uncommon for open source projects as a new project, lots of great functionality, lots of flexibility, pretty difficult to actually take and get started without a lot of hand-holding. So better documentation, better templates to be able to create applications for users to start to play with what they might want to do with OpenDaylight. These are things we recognize as necessary for the community and areas of focus for us. Improved processes and tooling just for our own sake, lots of infrastructure. Again, with a lot of folks, you got 200 constant contributors with many coming online all the time. So having a good way for them to work together is very important for us. So building out our both the infrastructure and the continuous integration, the continuous testing that we have as an open source project is very important to us, as well as flexibility in how these components go together, as well as consistency. I'll note that OpenStack is a great example of a community that has spent significant time building out their infrastructure to handle their own success. Right, again, there are thousands of folks who are actually working on OpenStack code. They have so many patches coming in all the time that they literally can't have enough machines to do serial implementation of each patch one after the other. So they created a technology and a process that actually allows for multiple patches to be done at the same time, built in continuous integration at the same time, and possible bugs in patches being removed with automatic regeneration so that you can do lots of parallel patches at the same time. It's very impressive. Leveraging those types of tools as well as building up our own is, again, part of what the community is working on. From a new project standpoint, laundry list, I know the slides are going to be out. I'll just mention a couple. So again, I showed the diagram of hydrogen. These are projects that are now part of Helium and the release that will be going out in September. An improved user interface, again, with one of the goals of making it easier to use and interact with OpenDaylight. Group policy plugin. So this is a broader effort to create a northbound API for doing policy-based management of network devices and links. It also has a sister project inside of OpenStack under the same name for doing group-based policy, and so that those two projects will be dovetailing, allowing that set of APIs within OpenStack to leverage the functionality within OpenDaylight. OpenDaylight Toolkit is really about using Maven archetypes as a technology to allow applications to be rapidly created for testing and for, again, basically proof of concepts. Dynamic resource reservation is a technique for creating physical connectivity through a network for virtual links. Table type patterns, also known as negotiable data path models. This is actually, I think we mentioned this in the work group as well on Tuesday, right? 1.3 of OpenFlow provides for so many extensions and options that it's very easy to not be interoperable. Well, the forwarding abstractions working group of ONF has been working on creating table type patterns that can be used and identified between a controller and switches for a common set of options that are allowed for the OpenFlow connectivity. Packet cable PCMM is an interesting one. This came from the Cable Labs, which is an industry consortia for cable companies in the US. And they wanted to be able to manage their end devices in addition to OpenFlow data path work within their networks. So they added a southbound plugin to be able to actually manage their devices through a controller. ODL root parent is basically internal housekeeping as a project to get everybody together for the common way of creating their bundle management in Java. The OpFlex protocol will be a new southbound protocol identified as part of those southbounds, as well as a southbound plugin for OpenContrail. So this will allow OpenContrail managed networks to be managed by OpenDaylight. AAA service is about accountability, accounting authentication, and access control. And it dovetails into a larger cross-project activity around general security. Our L2 switch functionality, we want to pull out and actually separate it as a separate entity within the controller so that more flexibility and different types of technologies can be applied there. as well as a service function chaining set of APIs that will be introduced. And then being able to ensure that you've got security and a secure environment from boot all the way through operation is an activity that the Secure Network Bootstrapping Infrastructure project is doing. Lots of ways of getting started and involved for developers. The wiki at OpenDaylight.org is the best place. Users and getting on the mailing list. We have a newsletter if you want to keep track of us. You can go to lists.opendaylight.org for developer lists. Go to the actual OpenDaylight.org site to get on the newsletter. If you're interested in understanding more about what the controller can do, go to the YouTube channel that we have. There are many great videos that we've posted there. And otherwise, again, we're on Twitter and again, OpenDaylight.org. So with that, I greatly appreciate your attention.
Thank you very much, Phil. That's really interesting, and open source is going to be very important in the future for this, right? So just like Java or like Linux, it's going to be a key enabler. Now, Phil, when you talk about a community, I think you're really talking about the developers, right? The people that are actively participating in your project. That's a little bit different to the end users, right? What do you think?
And finish off with where to find out more about the project. With what OpenDaylight is, again, from an open source community standpoint, we're really trying to bring the industry together to create a common platform that everybody can use as the basis for their SDN solutions. As I mentioned on Tuesday in the workshop, we need to consider open source never as a solution, but really as a technology. Many people take open source technologies and they combine them together. They add their own additional functionality around it. They add support, they add training, they add all the infrastructure necessary to create a solution for their end users. But by and large, technologies and different participants can take that platform and they can modify it to solve their specific needs. One of the great benefits about open source is that by having such a pluggable architecture where everybody can combine to build their own additional functionality to serve their own particular needs, it's often very leverageable by other members in the community. This is one of the reasons why open source is the basis of very, very significantly rapid innovation in a variety of places. One of the oldest examples is Linux. And if you look at Linux, as an open source technology, again, being a pluggable platform, allowing different organizations to be able to leverage that technology. Thank you very much for that introduction. So, as he mentioned, I work for OpenDaylight, and I by and large manage the overall open source community around OpenDaylight, as well as help to manage the nonprofit organization that supports OpenDaylight. I'm going to talk a little bit about what OpenDaylight is. It seems as though there's probably a pretty significant diversity within the crowd as far as those very familiar with OpenDaylight and those maybe not so much. So I'm going to cover exactly what OpenDaylight is, what our goals are, kind of talk about where we are, what the current release is doing, as well as what the next release is looking like. And open source is not a solution. And so that's something very important to remember. By getting the industry together and working together on a common platform, the goal here is to actually significantly accelerate the adoption of SDN by creating this common platform that everybody can use. We've had a great deal of success in bringing many of the industry players together to work on this common platform. You'll notice that the most successful open source projects are actually very pluggable and very platform-centric. There are many different components of open source that are available today. And again, the most successful are ones that are created in such a way so that different technology has allowed it to rapidly and consistently adopt new capabilities of hardware and the rest of the ecosystem around servers. OpenStack is similar and has been around for the last 4 years now, 3.5. OpenStack is also a very solid platform for doing cloud work with many different organizations contributing to it. It's a very pluggable architecture, so it's very extensible, and it continues to grow in functionality at a very, very rapid rate. Similarly, OpenDaylight, as a pluggable architecture, is looking to do that for the SDN ecosystem and also to help facilitate NFV.